Video opens with stunning artist-rendered visuals of Saturn and its largest moon, Titan, shrouded in a thick orange haze. Imagine a world, far from our own, where lakes and rivers aren't filled with water, but with liquid methane. A place where it rains gasoline from an orange sky and ice is as hard as rock. This isn't science fiction. This is Titan, Saturn's largest moon. And today, we're diving deep into its alien seas. Hello, everyone, and welcome back to the channel. If you're fascinated by the mysteries of our solar system, you've come to the right place. Today, we're embarking on an incredible journey to one of the most Earth-like, yet profoundly alien worlds we've ever discovered, Titan. So buckle up, because what we're about to explore will challenge everything you thought you knew about lakes, weather, and even life itself. Cut to an animation showing the Cassini spacecraft arriving at Saturn and deploying the Huygens probe. Our story begins with a daring mission. For years, astronomers peered through telescopes, puzzled by Titan's thick, impenetrable atmosphere. What lay beneath that hazy veil? The answer arrived with the Cassini-Huygens mission. In 2005, the Huygens probe made a historic descent, parachuting through the thick orange clouds. As it plunged, it sent back the very first images from Titan's surface. What it revealed was breathtaking, a landscape eerily similar to Earth's, carved by liquid. But this wasn't water. At a chilling minus 179 degrees Celsius, water on Titan is frozen solid, forming the bedrock and mountains. The liquid carving these channels, filling these vast lakes, is something else entirely. Methane and ethane, which are gases on Earth, but liquids in Titan's extreme cold. Show a map of Titan's polar regions, highlighting the major lakes like Kraken Mare, Lighthouse Mare, and Punga Mare. Using radar that could pierce through the haze, the Cassini orbiter mapped Titan's surface, revealing a stunning hydrogeological system. Concentrated at the poles are vast, dark patches. These are Titan's Great Lakes. The largest, Kraken Mare, is immense, larger than all of North America's Great Lakes combined. Then there's Lighthouse Mare, so deep and so clear to radar that scientists could actually map its seafloor. And Punga Mare, the third largest. These aren't just puddles. They are complex, dynamic bodies of liquid, complete with shorelines, islands, and even waves. So, what would it be like to actually stand on the shore of one of these methane seas? First, you'd need a seriously advanced spacesuit to protect you from the crushing pressure and extreme cold. The sky above would be a perpetual, hazy orange twilight, about as bright as a moonlit night on Earth. Saturn would hang majestically in the sky, a pale, ringed giant. The water lapping at your feet would be a clear, non-polar liquid, methane. It would be viscous, slightly thicker than water, and incredibly cold. The sand on the beach wouldn't be silicate rock like on Earth, but rather grains of water ice and solid organic compounds that have rained down from the atmosphere. An animation depicts the methane cycle on Titan, similar to Earth's water cycle. Just like Earth has a water cycle, Titan has a methane cycle. The sun's weak rays cause methane to evaporate from the lakes. It forms clouds, which then drift across the moon and eventually produce rain, not of water but of liquid methane. This rain forms rivers that carve canyons and deltas into the icy landscape before flowing back into the Great Lakes. We've seen evidence of this in Cassini's images. Vast river networks and dried-up lake beds, showing that this cycle has been shaping Titan for billions of years. It's a process so familiar, yet happening with completely alien chemistry. One of the most mind-bending discoveries about Titan's lakes is something called magic islands. In a series of radar images taken over time, scientists noticed bright features appearing and disappearing within the lakes. What could they be? Were they phantom islands? The leading theory is that these are actually vast fields of nitrogen bubbles. Methane-rich rains, colder and denser, might be sinking to the lake bed, warming up and releasing dissolved nitrogen gas, which then fizzes up to the surface like bubbles in a soda. Imagine seas that literally fizz. This tells us that these alien lakes are not static, but are active, changing environments. Transition to visuals of proposed future missions, like a robotic submarine or boat exploring the lakes. This incredible world is just begging for further exploration. Imagine sending a submarine to plumb the depths of Kraken Mare. What would it find? Could there be strange cryovolcanoes on the lake bed, spewing a slurry of water and ammonia from Titan's interior? This isn't just a dream. NASA is actively developing missions to return to Titan. One concept, the Titan submarine, would do just that. Autonomously explore the bottom of a methane sea, analyzing its composition and searching for clues about the moon's geology, and just maybe its biology. And that brings us to the ultimate question. Could there be life in these methane lakes? It certainly wouldn't be life as we know it. Any life on Titan would have to be based on a completely different biochemistry, one that thrives in liquid methane instead of water. Perhaps there are organisms with cell membranes made of different lipids that could function in the extreme cold. They might metabolize acetylene and breathe hydrogen instead of oxygen. While we have no evidence for it yet, Titan offers the tantalizing possibility that life can arise in conditions vastly different from Earth's. It forces us to broaden our definition of a habitable world. Discovering life on Titan, no matter how simple, would be one of the most profound discoveries in human history. Titan is a world of breathtaking paradoxes. It has mountains of ice, rivers of natural gas, and an atmosphere thicker than our own. It's a snapshot of a primordial Earth, perhaps, but locked in a deep freeze with an alien chemical twist. Every new piece of data we get from this distant moon only deepens the mystery and heightens our desire to go back. The journey to understand Titan's methane lakes is more than just planetary science. It's a journey to understand the limits of nature and the potential for life to exist in the cosmos. It reminds us that our solar system is filled with wonders that are stranger and more magnificent than we can possibly imagine. Thank you so much for joining me on this voyage to the seas of Titan. What do you think we'll find when we finally send a submarine to explore them? Let me know your thoughts in the comments below. If you enjoyed this cosmic journey, please give this video a thumbs up and consider subscribing for more adventures into the great unknown. Until next time, keep looking up.